Compression ratio is explained by the small diagram. This is the engine cylinder, single cylinder. The piston at the topmost position is called the top dead center. The piston at the bottommost position in the cylinder is called the bottom dead center. Here you see the piston is connected to the connecting rod. There is a gudgeon pin through a gudgeon pin. It's called the small end of the connecting rod. Now what is swept volume? Vs, which I mentioned in the equation. Vs is the swept volume from between TDC and BDC. Clearance volume is above the TDC. This is where the charge is compressed and it is either ignited by a spark plug or self-ignition in the case of CI engine. Coming to the third operation, cycle of operation, the spark ignites the mixture, or in the case of petrol engine, or the injector sprays diesel. This is during the suction stroke. Combustion energy, the next stage, the combustion energy, once the mixture is ignited or the diesel is ignited, the combustion energy, a tremendous amount of energy in the form of heat and pressure is released, and that energy that burned after burning of the fuel pushes the piston downwards from the TDC to the BDC. Pushing it down and through the connecting rod, which is connected to the crankshaft. So this motion of the piston, vertical motion of the piston, is converted into the rotary motion of the crankshaft, and the crankshaft in turn is connected to any particular machine through a flywheel, clutch, and to the gearbox, any machine we want to run. Four-stroke, now we come to the four-stroke petrol engine. Before that, I think it's pertinent to explain to you the various moving parts inside a engine cylinder. This is a single cylinder spark ignition engine. It's a cross section, the inlet valve, exhaust valve, the valve springs below the valve heads, inlet port for the charge to come inside the cylinder, the exhaust port for the burnt gases to be released. As I mentioned earlier, the top dead center of the piston, the bottom dead center. This is the displacement volume or the swept volume which I mentioned earlier. Cooling fins have been provided. That means this is a two-stroke engine and used in two-wheelers, and the air, rushing air against the two-wheeler helps cool the engine. The piston is connected to a connecting rod. The pin here is called the wrist pin or the gudgeon pin. In USA it's called the wrist pin. Connecting rod, this is the small end of the connecting rod connected inside the piston, and this is called the big end. This is connected to the crank pin. Crank pin, which is part of the crankshaft. This is the crank. This is the crankcase. The crankcase is normally filled with oil for lubrication. So having seen the parts, now we can study the 4-stroke petrol engine. The 4-stroke petrol engine was invented by a German by the name Nicholas Otto in the year 1876. It is also called a constant volume or Otto cycle. There are basically 5 operations in any 4-stroke engine. They are suction, compression, combustion, expansion and exhaust. Suction takes place for inducting the charge into the cylinder. Once the charge is inducted, it has to be compressed into the clearance volume above the piston. That stroke is called the compression stroke. The third is the combustion stroke, in which the spark or self-ignition takes place and combustion takes place, releasing a large amount of energy, temperature and pressure. That causes the piston to move down, and that is called the expansion stroke. And finally, the exhaust. These are the operations, but the strokes are only 4: suction, compression, expansion or power stroke and exhaust. To know the power developed, there is something known as an indicator diagram during the research stages of an engine. The indicator diagrams are plotted. What are indicator diagrams? It's basically a PV diagram. P on the y-axis and volume on the x-axis. Now, as I said, this is a constant volume because the volume is constant. Inside the cylinder, the volume of the cylinder is constant. It doesn't change. So let us look at these strokes and how this is plotted. The first stroke was the suction stroke. Suction 0 to 1. This is the atmospheric pressure. Suction is below the atmospheric pressure. Then only a suction will be created, and the port is small, relatively small, for so much of charge to go in. So by keeping it below atmospheric pressure, the charge will speedily fill into the cylinder 0 to 1. Second is compression from 1 to 2. Here at constant volume, the pressure of the charge rises much above the atmospheric. Then 2 to 3 is the power stroke. From 2 to 3 at constant volume, after ignition, self-ignition or igniting, the charge, temperature, pressure rises rapidly in a matter of milliseconds from 2 to 3. Thereafter, from 3 to 4 is the expansion stroke. The charge, burnt gases expand and push down the piston from 3 to 4. And then from 4 to 1 is the exhaust. From 4 to 0, this is the exhaust stroke. It will always be above atmospheric because the port is again small and within that short span, probably all the gases are generally not released. Now in this figure, what is the gross work done by this engine? The area 1, 2, 3, 4 is the gross work done by the engine. But there are pumping losses. By pumping losses means charge getting into the cylinder and the exhaust getting out of the cylinder. There are losses, frictional losses, other losses. And that's why this is represented by 0, 4, 1. This is called the negative loop because this has to be subtracted because of these losses. These has to be subtracted from the gross work done. Now this is the ideal indicator diagram, which should be, but in reality it is not so because of the reasons which I have already stated. So the actual indicator diagram in a research laboratory, when they plot it, it will be zero to 1 suction, 1 to 2 compression, 2 to 3 power stroke, expansion and exhaust. Now in the next lecture, we will study the 4-stroke diesel engine and see what are the differences. Basically, the 4-stroke diesel engine is at constant pressure. This was at constant volume, and a diesel engine works on the principle of constant pressure. Thank you.